In this video, we are going to discuss about what happens to the zygote after fertilization, what are all the development it undergoes, and what are all the progressions it undergoes up to the second week. Right. I hope you all know that oocyte containing two haploid nuclei is called as oocyte. That is one female pronucleus and one male pronucleus. As usual, the oocyte is surrounded by Zona Pellucida. So this is the female pronucleus and this is the male pronucleus, and a oocyte with two pronuclei or two nucleus. Two nuclei is called as oocyte. See, oocyte with female pronuclei and a male pronuclei. Female pronucleus and male pronucleus. Okay. And the oocyte being surrounded by a glycoproteinaceous layer called the Zona Pellucida. Right. What happens further to this oocyte? On the day 1 of fertilization, so this is the oocyte. Within that, on the day 1 of fertilization, what develops? The mitotic spindle develops. And the chromosomes within the nuclei get themselves arranged on the mitotic spindle. Let this be the maternal chromosome and let this be the paternal chromosome. Right. On day 1 of fertilization, fertilization takes place, right? During that, the chromosomes of both the nuclei arrange themselves on the mitotic spindle like this. As usual, the oocyte is surrounded by a glycoproteinaceous layer called the Zona Pellucida. So now this is called as the zygote, single-celled zygote. After this, the cell prepares itself for the cleavage. How it prepares means the chromosomes of the both pronuclei arrange themselves on the cleavage spindle, the mitotic spindle, and they divide longitudinally. They divide longitudinally like this, and the sister chromatids start moving towards the opposite pole. So like this, the sister chromatids start moving towards the opposite pole. So what happens next? A cleavage furrow appears in the middle. So cleavage furrow appears like this in the middle. So this is the initiation for the cleavage of a zygote. So see, this is surrounded by Zona Pellucida. It is the oocyte, that is oocyte. Literally speaking, it is the oocyte because it contains two pronuclei, right? So oocyte containing two nuclei are commonly called as oocyte. So they are containing two pronuclei, and for the initiation of cleavage, the chromosomes within the nuclei arrange themselves on cleavage spindle or called mitotic spindle. So they themselves arrange on the mitotic spindle. So on the first day of fertilization itself, it prepares it for the cleavage. So from day 1 onwards, it progresses towards the cleavage. So what happens? The chromosomes are arranged on the mitotic spindle, and as soon as the longitudinal division starts, the sister chromatids start moving towards the opposite pole. So there arises a cleavage furrow in the middle. Longitudinally, there arises a cleavage furrow. So this is what happens in day 1. What happens during day 2? So the cleavage is completed. So a single cell is converted into two cell. That is two-celled stage. How? So there arises a cleavage furrow in the middle, as I already said. Thus, a single cell is converted into two cell. So this is two-celled stage. Which is observed on the second day after the fertilization. On the second day itself, the cell undergoes a division to form four-celled stage. So this is Zona Pellucida, all you know. So again it undergoes cleavage. So it produces four cells. So on day 2 itself, it again undergoes cleavage to form an 8-cell stage. So this is 4-celled stage, 8-celled stage. So what happens on day 2 is, so 2-celled stage again it undergoes cleavage to form 4 cells. 4 cells again undergo cleavage to form 8 cells. All these happen on day 2 itself. Do remember that, do not forget to remember that all these processes of fertilization and cleavage all takes place in the fallopian tube. So now we're gonna to see what happens on day 3. Right. What happens on day 3? This is Zona Pellucida. All you know that. What was the result at the end of day 2? It was an 8-celled stage of the zygote. Of course, all you know that. So this is 8-celled stage at the end of day 2, right? So at day 3, this 8-celled stage undergoes cleavage to form a 16-celled stage. This 16-celled stage of embryo is called morula. I hope you all know what are these cells. These cells are called as blastomeres. The cells inside the embryo which undergoes rapid division, those cells are called the blastomeres. So in the morula, all the cells are very small and contains very little cytoplasm. All these cells contain very little cytoplasm. So now what happens at the end of day 3 or at the onset of day 4? So this 16-celled morula from the fallopian tube, it falls into the uterine cavity when around day 3 and day 4. So now the morula is in the uterine cavity. You already know that this is the Zona Pellucida. So what happens at this stage is the morula, the cells within the morula, that is the blastomeres, only some of the blastomeres alone come close to each other at the center of the embryo. That is 16-celled embryo. Only few cells come close to each other, that is compactly packed at the center. So the other cells are left behind. Like that. This process takes place within the uterine cavity. Once the morula has once the 16-celled embryo falls into the uterine cavity, it undergoes a process called compactization. That is, few cells just come close to each other and they form a mass in the center, leaving some of the cells behind. So this forms some outer cell mass and the inner cell mass. Of course, the outer cell mass are also just quite closer to the inner cell mass. For easy understanding, I have shown more space, that is lot space. So you can see this is the Zona Pellucida. The inner cell mass, after compactization, the inner cell mass are grouped together at the center of the embryo. And of course there are, let me show you that in different color. The outer cell mass. Right. Of course, till now it is called as a morula, there is no doubt. So about around day 4 and day 5, the morula floats in the uterine fluid. So still now it is called as morula, even after the formation of a outer cell mass and inner cell mass, it is called as morula. So after this, what happens? The fluid within the uterine cavity just starts entering through Zona Pellucida into the cell masses. So the fluid from the uterine cavity enters the cavity in between the cell masses. So what happens now? The Zona Pellucida starts disintegrating. So now the Zona Pellucida has started disintegrating and the fluid within the uterine cavity just starts entering into the cavities between the cells. So of course you all know that this is the outer cell mass. So this is the outer cell mass. The inner cell mass lies within the outer cell mass, right? So why did I draw these cells opposing on one side? There is a reason behind that. So as I said earlier, the fluid within the uterine cavity starts entering the cell masses, the cavities within the cell masses. So the fluid which has entered just pulls all the blastomeres, that is the inner cell mass, on one side, that is opposing on one side. So now see, this is the outer cell mass and this is inner cell mass, and this is the fluid filled cavity with uterine milk. It's nothing but the fluid which entered from the uterine cavity, right? What is this called at this stage? It is called as blastocyst. So the inner cell mass is called the embryoblast and the outer cell mass is called as trophoblast. So this later gives rise to an embryo, and this gives rise to placenta. You know what is this fluid-filled cavity is called as? Fluid-filled cavity in the blastocyst is called as blastocele. It gives rise to yolk sac. So have you ever wondered why the name blastocyst? It is because the rapidly multiplying cells are called as blast cells. Right. And the fluid-filled cavity is called as cyst. Since it contains both the blast cells and the cyst, together it is called as blastocyst. So all these events take place till the 5th day. Right. What happens at the 6th day? At 6th day, the master event occurs. What is that master event? It is the implantation. So the late morula and the early blastocyst will be floating the uterine fluid in the day 4 and day 5. After that, at the 6th day, at about 6th day, the implantation occurs. So before discussing about the implantation, where it occurs and how it occurs, I would like to discuss about how the endometrium prepare itself during the pre-ovulation or at ovulatory phase or at the post-ovulatory period. How it prepare itself for receiving an fertilized ovum, that is for the implantation, how it prepares itself. Let us take a look. So in the pre-ovulatory phase, the follicle stimulating hormone and the luteinizing hormone levels will be very high. Due to the stimulation of the follicle stimulating hormone, the follicle starts growing within the ovary, right? So from the primordial follicle, it develops into primary follicle and then into the secondary follicle and then into mature Graafian follicle, right? It is due to the stimulation of the FSH. So at that period, what is the condition at post-ovulatory phase? The FSH and LH will be low. So what happens at the period of ovulation? LH and FSH will be very high. LH will be very high. LH surge happens just 48 hours prior to the ovulation. So LH surge will be there, and in accordance with that, FSH will also be high, right? So the pre-ovulatory phase coincides with the follicular stage, because due to the stimulation of FSH, the follicle starts developing, starts growing, and that's what the pre-ovulatory phase coincides with the follicular stage, right? But the post-ovulatory phase coincides with the luteal stage. Why so? It coincides with the luteal stage? Because due to the development of the corpus luteum, right? After ovulation, the remaining portion of the follicles they degenerate into an yellow color mass that is called the corpus luteum. So post ovulation, it coincides with the luteal stage, right? So estrogen levels will be high during this period because estrogen is synthesized from the ovaries mainly, and the estrogen level will be somewhat low, but the progesterone level will be very high because corpus luteum secretes progesterone in order to maintain the endometrium for the implantation. It triggers the maintenance of the endometrium because the progesterone helps in the promotion of growth of the endometrial glands or arteries and everything. So the progesterone is the main hormone for implantation. It's responsible for implantation. So all these things together, what does this denote? What does this denote about the endometrium? It is the proliferative phase of the endometrium. That is, the endometrium is just proliferating. During the pre-ovulatory period, once the menstruation has completed, the endometrium starts proliferating itself. Okay, and post-ovulation. How does this mean to an endometrium? What does this mean? So it does denote the secretory stage of endometrium, because during this stage the glands, the blood vessels and everything is developed. It is fully developed, thoroughly developed for the implantation. So you see now, this is the uterus, and the upper portion is called the fundus, the middle portion is called the body, and below that it is the cervix and the vagina. So this is a fully developed endometrium. For that I have used a green color to denote the fully developed endometrial gland and the spiral arteries rising from the endometrium. So the blastocyst usually gets attached to the body of the uterus, either anterior or in the posterior wall, right? Do you know what are the layers of the endometrium? See, this is the perimetrium, the outer wall, right? And let this be the perimetrium. Right, then it is the myometrium. And after that it is the endometrium. In the endometrium, the layer closer to the myometrium is called the basal layer. And after that it is the spongy layer. And after that it is the compact layer, to which the embryo attaches itself, right? So during the menstruation, it is only the compact layer under the spongy layer is lost. It is only the compact and spongy layer last, but the basal layer never peels off from the endometrium. That is, it never peels off from the uterus during the menstruation. It is only the compact layer and the spongy layer last during the menstrual period. That is during the menstruation. So you see, this is the epithelial cells lining the endometrium. Have you ever wondered how this blastocyst gets attached to the endometrium? It is by the specialized molecules called selectins. It forms a hook-like a structure. The receptors for selectins are located in the endometrial cells, right? So when the blastocyst comes in close contact with the endometrium, the selectins from the blastocyst rises, and the receptors in the endometrium for the selectins catch hold of the selectin molecules that arises from the blastocyst, and it helps in the implantation of the blastocyst. So the molecule is called as selectins, and this implantation is further strengthened by integrins.